Hi everyone, in today's video, we're going to talk about length and midpoint of a line. Before we delve in, we need to know some key vocabularies and notations. So first, we need to know how we can denote a line segment. We use two capital letters, indicate the two endpoints, and sometimes we also use a dash on top of these two letters. So, for example, if we have a line segment like this with two endpoints and A, point A and E, we can say this is line segment AE. The second key point is how can we denote a point? So we use a capital letter to represent the point itself, the name of the point, and then we use a bracket with two coordinates inside. The first one is the x coordinate and then comma, and the second one is the y coordinate. And also we need to know how can we represent or denote a set of points. So a set of points is just a list of multiple points with a curl inside a curly bracket. And now let's delve right into the distance formula for any line segment. So the key to distance formula is actually something we have already learned before, Pythagorean theorem. Let's do a simple review. The Pythagorean theorem is simply a squared plus b squared equal to c squared. But how can we apply this theorem to the distance formula for a line segment? So the key is to construct a right-angled triangle. Something like this. So we want the right angle at the extended line segment right here, such that we have this right angle triangle ABC, right triangle ABC. Inside this triangle, we can see that based on Pythagorean theorem, the sum of the square of the two legs, which is AC and BC, is the square of the hypotenuse AB. And AB is exactly the distance that we are looking for, the distance of the line segment that we are looking for. If we isolate B by square rooting each side, we can get AB equal to square root of AC squared plus BC squared. Now, what is AC and what is the distance of BC respectively? So, first we need to figure out what is the coordinate of point C. So we can see that since A, we can say that it's x1 and y1. So we can see that this point right here is x1 and this right here is y1. Similarly, for B is x2, y2. So this point corresponding to here is definitely x2 and this point right here is definitely y2. So for point C, we can clearly see that it has a x coordinate of x2 and the y coordinate of y1. So the coordinates of point C should be x2, y1. So now we can continue to figure out what is the distance for AC and what is the distance for BC. So for AC, which is distance, this distance right here, we can clearly see that this is the distance right in the middle. So this distance, which is x2 minus x1. What is BC? BC is the distance right here. And we can see that it is actually the distance between y1 and y2. So BC, the distance for BC is exactly equal to y2 minus y1 squared. And this is the exact form for distance formula for line segment. So the distance formula for any line segment AB is equal to x2 minus x1 squared plus y2 minus y1 squared. And the precondition is that we say A is x1, y1, and B is x2, y2. So now let's use this formula to try to solve a question. So example number 1. Determine the length of the line below. So we can see that we have 2 points on this plane. One is A, -5, -3, and B, 7, 6. So this -5 is x1, -3 is y1, 7 is x2, and 6 is y2. So apply our distance formula. This AB should be equal to square root of x2 minus x1 squared plus y2 minus y1 squared. And we can substitute the numbers in. x2 minus x1 is 7 minus -5 squared plus y2 is 6 minus y1 -3. We can obtain something like 7 minus -5 is 7 plus 5, which is 12. 6 minus -3 is 6 plus 3, which is 9. And this thing would equal to -144 plus 81, which is root of 2 to 5. And this is 15, because 2 to 5 is 15 squared. So the square root of 225 is 15. So by basically applying this formula and substituting the corresponding value for the coordinates of point A and B, we can obtain the exact distance for line segment AB. What if the graph is not given, such as this example right here? Find the exact value of the line segment connecting point G, -25, 3, to H, -17, -5. So we still want to apply this formula right here. So distance formula, we're trying to find the distance for line segment GH. So this should also equal to x2 minus x1 plus y2 minus y1. But before that, we should also define which one's x1, which one's y1, which one's x2, and which one's y2. So let's just say this one's x1, and to keep it consistent, this should be y1, not y2. The index should be the same. And let's just say this right here for h is x2 and y2. And now we can simply substitute every value in. x2 minus x1 is -17 minus -25 squared plus y2 minus y1 squared. And after simplifying, -17 minus -5, which is -17 plus 25, which is 8 squared, plus -5 minus 3, -8 squared, 64. It's also 8 squared. So we can get square root 64 plus 64. We can get the square root of 128. And after simplification, we can get 8 root 2. And this would be the exact value for the distance of line segment GH. So this is all the content for the distance formula for any line segment on a Cartesian plane. And next, let's talk about midpoint of a line. So first, what is the definition of a midpoint? So a midpoint represents the middle of the line segment. It is equidistant from both endpoints, and it simply bisects the line segment. So let's first look at a investigation. Determine the midpoint of the following line segment. So we have this line segment right here with two endpoints A and B. And we can simply see that for A, it has a coordinate of 1, 5, and for B, it has 2, 5. So since the midpoint is the middle of the line segment, so the midpoint would be somewhere right in the middle of line segment AB. So since this is a horizontal line, this midpoint, let's say M, the coordinate of M should also be something which is the X value right here. And the Y value is also 5 because it's all on this straight horizontal line right here. So the key is how can we find this X value right here? So we need to recognize that this X value here, let's say X value for M is the average of the X value for point A and point B. So how does that work? So the X value of point M should equal to the X value of A plus the X value of B over 2. So this is the arithmetic mean or average of the two X coordinates. And ideally, we will get 1 plus 2 over 2, which is 1.5. And so technically, this would be a 1.5. And double check with the definition. So the midpoint should be equidistant from both endpoints. And we can clearly see that this distance right here is 0.5, and this distance right here is also 0.5. So yes, this is the midpoint, the X coordinate of the midpoint M for line segment AB. So the midpoint M would have a coordinate of 1.55. Let's look at another investigation. So on the previous example, our line segment is horizontal. What about when we have a line segment that is slanted, that is not horizontal? So still, we want to first identify the coordinates. So this is 2, 1, and this is 9, 7. So this time, we want to recognize that if the midpoint is right here, it would have a y coordinate somewhere right here and a x coordinate somewhere here. We want to recognize that this time, both the x value and the y value of this midpoint are both the average of the x value of A and B and y value of A and B respectively. In other words, the x value for this midterm M should be the arithmetic mean or the average of the x value of point A and absolute value, the x value for point B. And similarly, the y value of M should be the average of the y value of A and the y value of B. Just like this. So based on this idea, we can calculate the x value and the y value of M. So the x value of M should be the average of the x value of A and the x value of B, which is 5.5. And the y value of M is also the average of the y value of A, which is 1, and the y value of B, which is 7. So 4. So we can see that the coordinates of point M will be 5.5, 4. So now, if we make a a generalization of this formula. If we have any line segment, how can we find the midpoint? So we want to recognize that the midpoint, the coordinates of the midpoint, is just the average of the two endpoints. So this would be our midpoint coordinates formula for any line segments on a 2D plane. So now let's apply this formula to some examples. Let's move this down a bit so we can see it. Okay, so this time we want to determine the midpoint of line segments that join these 2 points, P and Q. No graph is given, but it's totally fine because the only thing we need to do is to consistently define the coordinates as x1, y1 and x2, y2. And now it's just a simple substitution. So this would be x1 plus x2 divided by 2 and y1 plus y2 divided by 2, which will give us a -1 and 2. So this will be the coordinate of the midpoint. And the last example of today will be a harder challenge. Determine the midpoint of the line segment with endpoint P, which has a coordinate of w plus 3 and 2w, endpoint Q, which has coordinates of 5w minus 1 and 7w plus 1. So, how can we do this? We still apply the same formula. Let me just copy this formula down real quick. So the midterm of any line segment would be x1 plus x2 over 2 and y1 plus y2 over 2. So the first step always is to consistently define these as x1, y1, and x2, y2. And then don't be afraid of these variables and binomials, monomials. We still simply substitute them in. So for midterm m, we will have x1 plus x2 is w plus 3 plus 5w minus 1 over 2 and 2w plus 7w plus 1 over 2. Now we do some simplification. So for this one, on the numerator we will have 6w minus 4 plus 2 and over 2, which we can extract a 2 from the numerator, which will give us this. So we can divide 2 on both numerator and denominator. We will get 3w plus 1. And for this one, on the numerator, we will have 9w plus 1. And on the bottom, we have 1. We cannot extract any greatest common multiple from the numerator, so which means this is the simplified version. So at the end, we will have the coordinates of midpoint M is 3w plus 1 as the x coordinate and 9w plus 1 over 2 as the y coordinate. And this would be the simplified coordinates of the midpoint of that particular line segment, PQ. I think that's all for today. Thank you very much for watching.